Arkadaşlar merhaba. I remember our last class hour. We didn't solve questions about trigonometric substitutions. So I decided to spare our first uh, video class for trigonometric substitution. This okay. I think it is good. Yes. Trigonometric substitution. First, let's make an introduction. We are making a trigonometric substitution if we have in our integrand some expressions like that. If we have square of some function of x plus a constant number, then we apply substitution instead of that something, we should substitute square root of that constant times tangent theta. By writing C, I mean a constant number. It represents any constant number such as 2, 3, 6, 5, like that. And for box, I mean a function of x. Maybe it can be x or 2x or 3x or x minus 2, something like that. If we have square of something, I write box for it, plus a constant, we should apply substitution, c times tangent theta. Or maybe we have in our integrand square of something minus constant number. In that times, we should make substitutions, a constant times secant theta. Or maybe they may change their places. We can subtract square of something from a constant number. Then this substitution will be suitable. Of course, c times sine theta. Then, what is the four basic steps of taking integrals with trigonometric substitution? First, we should choose wisely which substitution should we apply. Choose suitable substitution. After that, we choose the suitable substitutions by using these formulas. We should turn everything, this is important, everything, that means including dx, not only integrand, but also we should write dx in terms of d theta, turn everything into theta. And then, maybe generally, we can have opportunity for simplification. So if we have such things, we should simplify. And after that, we will have a more simple integrand, and then we can easily integrate it. And at the last stage of our problem solving bit, the result of integration will be in terms of theta, but then we should turn back to x. We should again turn everything into x. Now we can start with questions of worksheet 4. Let's start with first question of worksheet 4. What was that question? Integral dx over square root of 9 plus x squared. So, What was our first stage? Choosing suitable substitution. If you want, you can pause the video at any stage of question, and it will be better for you. Try to solve it for yourself, and then you can continue watching. Yes, for this integrand, we have in the denominator, the complicated part of integrand is the denominator part, and inside the square root, we have 9 plus x squared. So we have some squares. This is in square form, and 9 is, it's also another square. We can consider it as a square of 3. So in our formula table, it is looking like which form? We have square of two things, and they are add up. So first one is the case. Hence, it will be better. We can choose substitution. X is equal to c times, which is 3, tangent theta. Hence, we completed our first step. Second one is turn everything in terms of theta. So in the denominator, we have 9 plus x squared, 9 plus, instead of x, we should write 3 times tangent theta. And square of x is 9 times tangent square theta. What about numerator? Numerator, it is written dx, but we can't use x variable. We should turn everything into theta. So we should calculate dx. If x is equal to 3 times tangent theta, then dx is, by taking derivative of both sides of the equation, 3 times secant squared theta d theta. So instead of dx, we are writing 3 times secant squared theta d theta. And what is next step? In the next step, of course, we should use some trigonometric identities. What are they? In trigonometric substitution questions, only 2 of these identities we often use. What are they? Sine squared theta plus cosine squared theta is add up to 1, and tangent squared theta plus 1 is equal to secant squared theta. By using these 2 identities, we can also obtain another identities by solving one of them from the other. So from here, inside part of square root can be written in 9 parentheses, 1 plus tangent square theta. And from the identities, 1 plus tangent square theta is equal to secant square theta. So our integral will become 3 times secant square theta d theta over square root of 9 times secant square theta. What is that? 3 times secant square theta d theta over square root of 9 is 3, square root of secant square is secant theta, and we are ready to make simplifications and integration. 3's are cancelled, 1 of the secant is cancelled, and our integral will become secant theta d theta, which is equal to ln tangent theta plus secant theta plus a constant number c. So we integrate our integral, but result is in terms of theta. As a last step, we should turn into terms of x. And to make this, we can draw a triangle. What we have, x is equal to 3 times tangent theta was our substitution. From here, we can solve tangent theta as x over 3. Then we will draw a triangle which satisfies tangent theta is equal to x over 3. So if this angle is theta, to satisfy tangent theta is equal to x over 3, length of this side should be x and this side should be 3. By Pythagoras theorem, hypotenuse should be square root of x squared plus 9. And what should we need? We need tangent theta and secant theta. Tangent theta is, as we know, x over 3. What about secant theta? Secant theta is 1 over cosine theta, and 1 over cosine theta is, from this triangle, 3 over square root of x squared plus 9. So it will be equal to x squared plus 9 over 3. Then we can replace secant theta with this number. So our answer will be ln x over 3 plus square root of x squared plus 9 over 3 plus a constant number c. Now we are ready for second question. What is it? It is looking like first questions, but I am especially choose that question to emphasize their difference. 3 over square root of, previous question was 9 plus x squared, but this was 1 plus 9 times x squared. So what is the difference here? First, we choose suitable substitution and we decide which substitution is better. In denominator, we have 1 plus 9x squared. 1 is square of 1. And 9x squared is square of 3x. And our substitution rule is box is equal to c times tangent theta. But here, the box is, what is the box? 3x. So our substitution should be 3x is equal to c times, what is c? What is square root of our constant number? It is 1. 1 times tangent theta. Also, like previous question, we will in the need of information about dx. So hurriedly we can calculate it now. When we take its derivative, 3 times dx will be equal to derivative of tangent theta is secant square theta d theta. Now, as for the second step, we can write everything in terms of theta. Instead of 3 dx, we can write secant square theta d theta over square root of 1 plus 3x squared. 3x was tangent theta, so it will be tangent theta square, which is tangent square theta. Then, where is my Okay, trigonometric identity sheet. Tangent square theta plus 1 is equal to secant square theta. So we will have secant square theta d theta over square root of secant square theta, which will be only secant theta. Then our integral will be integral of secant theta d theta, and it is equal to ln tangent theta plus secant theta plus a constant. And tangent theta, we can read from our substitution, is equal to 3x from the triangle. If tangent theta is equal to 3x, then this side should be 3x, the length of this side should be 1, and length of hypotenuse is equal to 1 plus 9x squared. So, what is cosine theta? Cosine theta is equal to 1 over square root of 1 plus 9x squared. Hence, secant theta should be equal to square root of 1 plus 9x squared. Then, our result will be ln. Instead of tangent theta, we can write 3x. Instead of secant theta, we can write square root of 1 plus 9x squared plus a constant c. And this is the result. Then we can start question 5. Question 5 is integral of dx over in the square root 4x squared minus 49. Oh, yeah. What substitution should we use this time? A complicated part of our integrand is denominator. In the denominator, we have 4x squared minus 49. So, what do we have here? It is square of 4x squared is square of 2x, and 49 is square of 7. So we have square of something minus a constant number. So we should apply this substitution, square of something minus constant number, which means box is equal to c times secant theta. What is the box? Whose square we are taking? 2x. So our substitution should be 2x is equal to 7 times secant theta. Then we should write everything in terms of theta. Instead of 2x, we should write 7 times secant theta, but we should take its square, which will be 49 times secant square theta minus 49. And for the denominator, we have dx. So let's calculate dx. When we take derivative of both sides, 2 times dx will be equal to 7 times secant, derivative of secant theta is secant theta times tangent theta. So, but in denominator we have dx, not 2dx. So we can multiply and divide it by 2. So 1 over 2 times 2 dx, and 2 dx is equal to this. 7 times secant theta, tangent theta, d theta. And then we can write this one in 49 parentheses secant square theta minus 1, and by our trigonometric identities, if we solve, we, secant square theta minus 1 is equal to tangent square theta. So our integral will become 1 over 2 times 7 times. Also we can take, no, this 7 should be here because I need it. 7 times secant theta tangent theta d theta over square root of 49 times tangent square theta, which is equal to 1 over 2 times 7 times secant theta times tangent theta d theta over square root of 49 is 7, square root of tangent square is tangent. We can cancel them, and we will have 1 over 2 times integral of secant theta d theta, which is equal to 1 over 2 times ln tangent theta plus secant theta plus a constant c. And in the last step, we should turn everything into x again. We had chosen 2x is equal to 7 secant x. Let me check. Yes, 2x is equal to 7 secant x. Then secant x, secant theta. Then secant theta is equal to 2x over 7. Next step is draw a triangle which satisfies secant theta is equal to 2x over 7. If this is theta, secant means hypotenuse over, so hypotenuse should be 2x and length of this side should be 7. Let's check that. Secant will be equal to 2x over 7. And by Pythagoras theorem, length of this side should be 4x squared minus 49. And what was our answer was ln secant theta plus tangent theta plus a constant c. Instead of secant theta, we should write 2x over 7. And instead of tangent theta, we should write square root of 4x squared minus 49 over 7. Plus a constant c. So this was the result of the 5th question. Now let's start. Which question? We can omit question 6, 7, and yes, question 8. In the question 8, we have dx over x cubed times square root x squared minus 1. Now, should we have some addition or subtraction of square of two things? Let's consider. We can make our substitution in this region. We have square of x minus something. So square of box minus constant number is looking like second one. So x is equal to 1 times secant theta, will be good for our substitution. Hence, we replace every x with this one. Instead of x cubed, we can write secant cube theta. Instead of square root of x squared minus 1, we can write secant square theta minus 1. We replace everything in the denominator with x substitution. In denominator, we have dx. So let's calculate dx from here. If x is equal to secant theta, then dx is equal to derivative of secant theta is secant theta times tangent theta. So we are replacing this one with that. Next, if possible, we can make some simplifications. Secant square will remain in the denominator. And secant square theta minus 1 is equal to tangent square theta. So integral will become, in denominator we have tangent theta d theta. In the denominator, secant square theta left, and square root of tangent square, which is also equal to tangent theta. Hence, we can simplify these tangent thetas again. So we have d theta over secant theta. But remember that, what is secant theta? Secant theta means 1 over cosine theta. So 1 over secant theta means y x square. 1 over secant square theta means cosine square theta, d theta. Hence, to solve this question, we need another identity. But well, let me add these identities. Half-angel formulas. It's coming from half-angel formulas. Cosine square theta is equal to 1 plus cosine 2 theta over 2. And sine square theta is equal to 1 minus cosine 2 theta over 2. And we need this identity now. Instead of cosine square theta, we can write 1 plus cosine 2 theta over 2 d theta. Then result of the integral will be theta over 2 plus integral of cosine 2 theta is sine 2 theta over 2, but we have another 2 here. So sine 2 theta over 4 plus a constant c. Next, we should turn everything in terms of x. We have only information that x is equal to secant theta. So we should draw a triangle which satisfies x is equal to secant theta. If this is theta, hypotenuse should be x, this length should be 1, and from Pythagoras theorem, this length should be square root of x squared minus 1. Then what can we say from here about theta? Sine theta will be equal to square root of x squared minus 1 over x. And cosine theta is equal to 1 over x. But we need to calculate theta and sine 2 theta. Maybe from cosine theta, we can find theta is equal to, by taking arc cosine of both sides, theta will be equal to arc cosine 1 over x. But to find sine 2 theta, we need one more trigonometric identity. Sine 2 theta was equal to 2 times sine theta times cosine theta. That was a trigonometric identity. Then we can replace them in their places. 2 times, what was sine theta? Sine theta was square root of x squared minus 1 over x. Square root of x squared minus 1 over x. What is cosine theta? That was 1 over x. So it will be 2 times square root of x squared minus 1 over x squared. It was the sine 2 theta. So what is the result of integral? Theta over 2, which is arc cosine 1 over x over 2 plus sine 2 theta over 4 plus sine 2 theta over 4. So we divide this one by 4. X squared minus 1 over 2x squared and plus a constant. That was the answer of the 8th question. Now, question 13. In the question 13, dx over x squared minus 1 to the power of 3 over 2. Which substitution should be used here? We have square of function square of x minus a constant number. So it resembles square minus constant. It resembles to second one. C times box should be equal to C times second. So if we choose x is equal to, what is C? The constant number we use here 1. So C is 1. 1 times secant theta. Then integral will become dx over secant squared theta minus 1 to the power of 3 over 2. What is dx? If we take derivative of both sides, dx will be secant theta times tangent theta. Then integral d theta, of course, here. Secant theta times tangent theta d theta over secant square theta minus 1. Remember from the trigonometric identity, this is equal to tangent square theta. So tangent theta square, but also power of 3 over 2, which will be tangent cube theta. Then we can cancel tangent theta and tangent cube theta here. Secant theta, tangent theta d theta over tangent cube theta. We can cancel one of the tangents. So integral will be equal to secant theta d theta over tangent square theta. How can we continue after this step? By remembering tangent is equal to sine over cosine, secant is equal to 1 over cosine. If we replace them, for secant theta, I am writing 1 over cosine theta. And for tangent square theta, I should write sine square theta over cosine square theta, but denominator, I should write divided by cosine square theta, but denominator over denominator will be numerator. So I have cosine square theta here. then one of them will be cancelled. I will have cosine theta d theta over sine square theta. So this will become a trigonometric integral. We can make a substitution. U is equal to sine theta. Then we can check that is du in the integrand or not. Du is equal to cosine theta d theta. So integral will become cosine theta d theta will become du. Sine square theta will be u square. Hence, integration of 1 over u square is, which is u to the minus 2, this integral will be minus 1 over u plus a constant number c. But answer this time will be in terms of u. We should first turn back to variable theta, then turn back to variable x. Since u is equal to sine theta, we can write it minus 1 over sine theta plus constant c. We have x is equal to secant theta. Secant theta is equal to x. So draw a triangle such that this is satisfied. Since secant theta is equal to x, hypotenuse should be, if this is theta, hypotenuse should be x, and this length should be 1. This part should be x squared minus 1. Then sine theta will be length of opposite side over length of hypotenuse. So answer is minus 1 over sine theta. So minus 1 over sine theta will be, we should replace numerator and denominator, minus x over x squared minus 1 plus a constant c will be our answer. Okay, we can complete our first video class by question 15. It will be 1 minus x squared with power 3 over 2 over x to the 6 dx. Now we should decide wisely which substitution should we use. The complicated part this time in the denominator, it's actually 1 minus x squared. So we are subtracting some function of x from a constant number. So it resembles to third one. So our box should be c times sine theta. X should be equal to, in this question c will be 1 times sine theta. If we should choose this substitution, then dx will be cosine theta d theta. Next, we transform everything in terms of theta. So instead of 1 minus x squared, we can write 1 minus sine square theta with power 3 over 2 over x to the 6, which means sine theta to the 6. And instead of dx, we should write cosine theta d theta. 1 over sine square theta is, by trigonometric identities, 1 over sine square theta is, from here we can solve it, and we can see that it is cosine square theta. So it is cosine square theta with power 3 over 2 times cosine theta d theta over sine theta to the 6. this cosine square and in the power of divided by 2 are cancelled. So in the denominator we have cosine cube theta times cosine to the 4 theta. All of them will become cosine to the 4 theta d theta over sine to the 6 theta. And we can separate them as cosine to the 4 theta over sine to the 4 theta times 1 over sine square theta d theta. Or we can write it cotangent to the 4 theta times cosecant square theta d theta. Then it will become a trigonometric integral. This substitution should be good for it. Yeah. Consider it. We have cosine square theta d theta here. So we should choose something u such that its derivative should be cosecant square theta or its negative form. It will be better if we choose cotangent theta, because if we choose u is cotangent theta, its derivative will be minus cosecant square theta. So that after making suitable substitutions, we have integral of minus, instead of cotangent we can write u to the 4. Instead of cosecant square theta d theta we can write du. So result will be minus u to the 5 over 5 plus a constant c. But since u is equal to cotangent theta, it will be minus cotangent theta to the power of 5 over 5 plus a constant c. But we also need to turn back to x. What was our substitution? X is equal to sine theta. So we should draw a triangle which satisfies sine theta is equal to x. Or in other words, x over 1. What does it mean? If this is theta, this length should be x, and this length should be 1. And from Pythagoras theorem, this length should be 1 minus x squared. Which information we need? We need cotangent theta. Cotangent theta is length of this side over length of this side, which is square root of 1 minus x squared over x. Hence, result of our integral is minus 5 power of cotangent theta means 1 minus x squared to the power of 5 over 2. Instead of writing square root, I prefer to divide the power by 2 over x to the 5, but also we have another 5 in the denominator, plus a constant c will be our answer. So it's all. Or we can continue from the next topic in the next videos. I wish you a good week.